In today's video, I would like to introduce you a very nice problem of Indian Mathematical Olympiad edition 1995, question number 6. Here is the following information. Find all primes p for which we have this setup 2 to the p minus 1 is divided by p is a perfect square. Okay, this is very nice problem involving the prime numbers. So before I proceed with the solution, I'm going to remind you with a very important and useful formula. It's called Fermat-Leroux theorem. If you have a p as a prime not divide an integer, then we have this statement: a to the p minus 1 is a congruent to 1 mod p. Okay, so first of all, we are going to check with this theorem. Okay, so make sure we are going to, before we proceed with the solution, we are going to check the obvious case. We are going to check if the prime is even. Okay, then we move on to the next case to check maybe you have a prime as an odd number. So go ahead, pause this video if you would like to give that try to this problem. When we come back to see the full solution. Okay, let's get into the solution now. In order to have this one as a perfect square, we have to have this statement: 2 to the p minus 1 over p equals n square, for example, right? Since we have this left hand side of this equation is n square, which is an integer, that means p divide this term. Okay, this implies p divide 2 to the p minus 1. Okay, on the other, it's one equivalent 2 to the p minus 1 is a congruent to 1 mod p. This one is verifying the Fermat-Leroux theorem, because now it's 2 to the p minus 1 congruent to 1 mod p. That means p not divide number 2. Okay, that means p is not equal to 2. Okay, so when it's telling us p is a super equal to 3 as an odd number. Since we know that p is an odd number, that means we can rewrite it on this form: p equals 2m plus 1, where is the m is super equal to 1. As we know, is not every an integer m it can give you the prime number. This one can be odd, not prime. Okay, but there is a few of them can give you prime. So anyway, since prime number is written on this form, so we can go through this way. Okay, for this reason. Now I'm going to solve this one simply. So I have this expression: 2 to the p minus 1 divided by p equals n squared. That's mean I'm going to multiply side by side. It's giving me p here. Okay, since p equals 2m plus 1, I'm going to take number 1 to the left. I have p minus 1 equals 2m. That's mean p minus 1 is an even number. So I'm going to replace this one with a 2m. Okay, then I will have a factorable polynomial here. Now I'm allowed to factor out this one. So this one is giving me 2 to the m minus 1 factor 2 to the m plus 1 equals p is multiplied by n squared. So if you take a look carefully here, this is written on the form of two consecutive odd numbers: 2m plus 1. This one you have 2m minus 1. Both numbers are odd. They are written on the form of the consecutive odd numbers. Okay, so 2 to the m minus 1 are relatively prime. So since they are relatively prime, that means the right hand side of this equation must be relatively prime as well. So this one is giving me an idea how to factor out the right hand side of this equation. So I'm going to split this n square into two parts. Okay, so this one will be written on the form of p is multiplied by a square is multiplied by b square. Okay, if you have a square of the numbers, you can split it into two parts. Okay, but remember the GCD of these numbers a and b must equal to 1. Okay, because they are relatively primes. The same thing here, the GCD of 2m minus 1 and 2m plus 1 equals 1. Then we have p is a multiple of one of those, but p can pass over to the b square as a multiple. Okay, but it's okay, it's not going to affect our problem. If the p goes to the b square, we'll rename it as we did now. Okay, I'm going to break this one into two cases. So the case number 1 and case number 2. So case number 1, I will have 2m minus 1 equals pa square, and the other one I will have 2 to the m plus 1 equals b square. For the second case, I will have 2 to the m minus 1. I will have the inverse of this one. I will have b square here, 2 to the m plus 1. I will have p is multiplied by a square. So I'm going to go through each case. I'm going to start with this case. When I finish with this case, then I move on to the other one. So now I'm going to start with the second equation. I'm going to move over number 1 to the right side. I will have number 1 here, minus 1. This one will be written on this form, b minus 1 factor b plus 1. Okay, so since the left hand side of this equation is a power of 2, that means the right hand side of this equation must be a power of 2 as well. So this one is telling us b minus 1 is taking this form, 2 to the x, and b plus 1, it will be written on the form 2 to the y. Okay, in order to find b, x and y, I'm going to make the difference of these two equations by subtracting the big one minus small one. So we'll have this one minus this one. I will have number 2 here equals 2 to the y minus 2 to the x, where y is strictly superior than x, because we have this term is bigger than this term. Now I'm going to factor out this one. I will have 2 to the x. Since 2x is smaller than 2y, I'm going to make it as a common factor. I will have 2 to the x is multiplied by 2 to the y minus x minus 1. So if you take a look at this number, number 2 is written on the form of the product of two numbers. So this number is an even, this number is an odd. Okay, so this one is written on the form of 1 is multiplied by 2. Okay, since 2 is an even, is going to take this one. Since this one is an odd, you're going to take the number 1. So this one, 2 to the x must equal to 2 to the 1, and 2 to the y minus x minus 1 equals number 1. Because this one is an odd, this one is an even. That's mean x equals to 1. Okay, since x equal to 1, I'm going to replace number 1 into x. So I'm going, by taking minus 1 to the right side, I will have number 2 here. So the exponent 1, that's mean y minus 1 equal to 1. That's mean y equal to 2. Since I know the value of y equals 2, I'm going to replace it into this equation. So we'll have b plus 1 equals 2 to the 2, which is 4. That's mean b equals 4 minus 1 equals 3. Since I know the value of b equals 3, I'm going to take this value of b and insert it into second equation. Okay, so I will have this one, 2 to the m equals b square, which is 9 minus 1, which is 8. 8 is written in the form 2 to the 3. So that's mean m equals 3. Since m equals to 3, I'm going to replace m with its value. I will have p as a prime equals 2 is multiplied by 3, which is 6, plus 1, which is 7. Now I found the first prime. Okay, now I'm going to clean up this board and move on to the next case. Now we are in the second case. I'm going to work on the first equation. I'm going to take this minus 1 to the right. I will get 2 to the m equals b square plus 1. Okay, if you take a look at the left hand side of this equation, the left hand side of this equation is even. That's mean the right hand side of this equation must be even as well. That's mean b square plus 1 is even. So that's mean b square is a odd. That's mean b is a odd. Okay, since b is a odd, that's mean b will be written on this form, b equals 2n plus 1. Okay, now I'm going to calculate b square plus 1. I'm going to insert this fact into b and calculate b square plus 1. So b square plus 1 is giving us 2n plus 1 quinary square plus number 1. This one is giving us 4n square plus 4n plus 1 plus 1. Okay, that's mean plus 2. Okay, so since b square plus 1 equals 2m and equals to this expression, that means this one equals to m. Since m is super equal to 1, so I'm allowed to divide by number 2. Okay, so I'm going to divide by number 2. I will have 2n square plus 2n plus number 1 equals 2m minus 1. Now it's very clear here. The right hand side of this equation is an even, but the left hand side of this equation is an odd, because this one is an even, plus even is given as even, plus odd is given as odd. That means odd equals to even. So this one will be happened if m minus 1 equal to 0. In the other word, m equal to 1. M equal to 1. If m equal to 1, this one it will be 2 to the 0, which is equal to 1. Then it become odd. This one is already odd. I'm going to insert number 1 into this expression to find p. So then I will have p equals 2 is multiplied by 1 plus 1, which is equal to 3. Now I found p equals 3. So the only prime that I found p equals 3 and p equals to 7. I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.